Hello, welcome to Aerosip. In this video, we will look at a specific regulation called 25.562 Emergency Landing Conditions. We will see what it is, what is the purpose of it, what are the requirements of dynamic tests to show compliance to this regulation. Finally, I leave you with some references for further reading and improving your knowledge. Let us first see what this regulation is. Shown here is the extract from the EASA website. EASA 25 CS 25.562 is a regulation that focuses on the crashworthiness of aircraft seats and their ability to protect passengers during emergency landings or crash scenarios. This regulation is part of a larger set of airworthiness standards for large civil aircraft, which is clubbed under CS 25, which sets out the design and structural integrity requirements to ensure aircraft safety. What is the purpose of this regulation? In an emergency landing, seats and seat belts are the primary line of defense against injury. So, this regulation ensures that the passengers can survive high impact simulations with a minimized risk of severe injury by ensuring the seats, their attachments, and restraint systems such as seat belts are strong enough to protect passengers during a crash or emergency landing. It outlines the specific dynamic forces that the seat and the restraint system must be able to withstand to keep passengers safe. Important ones are the forward and downward deceleration forces that need to be accounted for in the design. 16G forward in the direction, 14G in the downward direction. Shown in this slide are the calculations using the information from the above regulation. For forward loading condition, an object traveling at velocity of 30 miles per hour, for example, coming to zero velocity in a matter of 0.085 seconds or 85 milliseconds. That develops the 16G deceleration. Similarly, for the downward loading condition. Shown here is the history of this particular regulation. So, no significant changes in today's version compared to the initial TS25 version that was published in 2003. Shown here is the extract from FAA website. There is perfect harmony between the two regulations for the EASA's certification specifications and federal aviation regulations as far as this particular specification is concerned. Shown here is the history of this regulation. Prior to 1988, there were no dynamic test requirements for the seat and attachment structures. So, the dynamic tests. To summarize the regulations, aircraft seats must be tested to withstand specific forces simulating the conditions of a crash. These tests apply to loads to the seats in different directions, forward and downward, as we just discussed, to simulate the effects of a hard landing or crash. For the 16G forward impact, the seat must be able to protect a passenger when the aircraft decelerates at 16 times the force of gravity in the forward direction. Similarly, for a 14G downward impact, it must protect the passengers up to 14 times the force of gravity in the vertical downward direction. Then the structure and the restraint system. So the seat frame, cushions, attachment points of the aircraft seat belt must be designed to remain intact and functional under these dynamic conditions. Head injury criteria. So that is a criteria that is used in the regulations. The head impact protection is assessed to minimize the risk of head injury during a crash. The seat belt must prevent excessive forward movement of the passenger while distributing the force across the body in a way that reduces this particular head injury criteria. A typical seat is shown here. Then comes the anthromo- anthropomorphic test device or ATD. We call it as dummy. So when testing, these test dummies are used, placed in the seat to measure the forces experienced by a human body. This ensures that not only does the seat remain intact, but the forces experienced by the passenger would be within the survivable limits. Considerations for different occupants, obviously. The regulations also cater for various um, passenger sizes, requiring testing to reflect the different body types to ensure safety for everyone from children to larger adults. Shown here is a typical dynamic test arrangement, and let us see what the performance measures are from the tests. Looking at the seat. So the seat, what is the requirement or the performance measure from the test? So the seat must remain attached at all points of attachment, although the structure may have yielded. Seats must not yield to the extent they would impede rapid evacuation of the aeroplane occupants. The next one is the seat belt and the upper torso restraint. So the straps that restrain the passenger must remain on the occupant's shoulder during the impact, and the tension loads in the individual straps must not exceed 794 kilograms if it is a single one. If there are dual ones are there, total port must not exceed the 907 kilograms. The next requirement is the lap safety. So the belt must remain on the occupant's pelvis during the impact. The maximum compressive load between the pelvis and the lumbar column of the dummy must not exceed 680 kilograms. Where leg injuries may result from contact with the seats and other structures, protection must be provided to prevent axially compressive loads exceeding 1021 in each femur. And each occupant must be protected from serious head injury. So, where head contact with the seats or other structure can occur, protection must be provided so that the head impact does not exceed the criteria, head injury criteria of 1000 units, and that is calculated by this equation. So, that concludes the requirement aspect of this particular regulation. And 9G seats are accepted, or there are still some 9G seats in certain aircrafts. Here are few cases. So the first case being the grandfathering rights. So grandfathering occurs when an older regulation, such as the requirement for 9G seats, are allowed to remain in effect on a certain aircraft, even after new regulations like the 16G seats that are there now have been implemented. This can happen in the case of an older aircraft that were originally certified under less stringent requirement, as we have seen in the history of the regulations, where retrofitting newer seats on those is not feasible. So an example is shown here for Boeing 747, where this particular requirement is not applicable. And the same 9G seats may be accepted in specific aircraft categories. They might provide some specific exemptions, and those exemptions are through implementation of enhanced seat belts, additional cabin safety measures, or procedural changes that mitigate the risk. These exemptions are granted on a case by case basis, typically for older aircraft where implementing the 16G is technically impractical. And here, finally, I leave you with these references for those who want to study this topic further. Thank you for watching.